fresh air into the building on a continuous basis. Why do we need fresh air inside the building? Well, you have kids. And what do kids do? They get sick. So circulating sick air between all the classrooms would be a bad thing. The other thing is it keeps our CO2 levels down minimal and below 700 parts per million, which is the point at which we all start to feel the effects of it and be tired, real groggy, and for kids and anyone in any environment, that's not productive. We're going to go ahead and turn off the power. We're going to identify components, what panels are where, and exactly how this system functions. So a dedicated outdoor air system brings in 100% fresh air at all points. That fresh air is brought in, assembly right here. Fresh air is introduced to the building 100% of the time. So like a standard air conditioner would be a supply and return. Here's your return. Air comes in here at all points. Behind this cabinet and through this door right here, we have a damper. This unit is not running, does not allow air to migrate into your occupied space. This damper inside of here is called an MOD, motor operated damper. As we turned it off, you can hear it closing. That's to make sure that when this unit's not running, cold air from outside is not migrating into your interior space. We have filters in this cabinet. We have filters right here. These being some of the most important filters. These filters have to be pulled out and chemically cleaned once a month. That's how dirty they get. Believe it or not, these were bright and shiny silver like that when they were first put in. Very easy to take these out. You remove the screws right here, pull these out, and they have to be chemically cleaned. You cannot just water rinse these. Simple Green is a perfect cleaner for them.
Simple Green?
Simple Green.
Okay.
Break them all out, put them up against the side of the unit or wherever you're going to clean them with a hose. Spray them down with Simple Green. Give it about 5 minutes. Rinse it off. You're going to see how much dirt actually comes out of here. Okay, this is for your large particulates. You can see they're black at this point.
Yep.
See how thick that filter is? If it's black here, it's black the rest of the way through too. Then we have secondary air filtration. It happens right here. That way any of the air that's being introduced to the building is being filtered. It's not being filtered for germs, but it is being filtered as far as air filtration can go for a MERV 8 filter. Air enters this cabinet and goes to what's called your ERV wheel. You guys know what an ERV wheel is? You guys ever seen one? Okay, ERV wheel is an energy recovery ventilator wheel. This is actually where you access all your piping that comes up for your coils. We're going to look at the ERV wheel from the side. That is your ERV wheel. What is its purpose? It is taking the air that is being brought inside of here. So if it's 90 degrees outside and we're trying to provide cooling to the building, but we want to bring in fresh air, how do we do that without introducing 90-degree air to the space? Well, we have a coil. That coil would have to work really hard on a continuous basis to cool 90-degree air to get down into the space. We really want to discharge like 55-degree air from our air conditioners, right? That coil would have to struggle. So to make it energy efficient, we recover some of the cool air that we're exhausting out of the building. So fresh air requires us to bring air in and take air out. If we just brought it in, we create a positive pressure in the building and everything would, all doors would push open on themselves, ceiling tiles would lift out of place. Whatever we supply in, we have to take out to the exhaust assembly. This is your exhaust blower motor. But between these 2 points, we have the ductwork that's coming back up, our return ductwork. The ERV wheel is on a constant spin basis. What it's doing is taking the air that's inside, creating a mixed air. It's trying to absorb some of the heat or reject some of the heat depending on heating or winter operation and make sure that we don't have to try to compensate for 40 degrees. So if it's 10 degrees outside and we're trying to supply 70 degrees to the space, I mean, we have to heat up 60 degrees worth of air before it goes downstairs. That energy recovery ventilator, the wheel, is going to pick up some of that heat before it's exhausted and send it back down into the space. Minimum every 3 months. This thing runs continuously in an occupied mode. That means whenever the schedule is set for this building, that motor and the other motor I'm going to show you are running. They are running every single day on a continuous basis. These have grease ports. Grease port located here. Grease port located on the back of the motor. Both of those grease ports need to be checked.
What grease do you recommend for those? I mean, any kind of grease?
Lithium bearing grease.
Oh, okay.
Lithium bearing grease. While the manufacturer does specify a particular type of grease, lithium bearing grease is acceptable. It's not as easy as just rolling this belt off of here. This thing is connected to a sled underneath. That sled, all these bolts have to be loosened. That sled has to be pulled back and then tightened back in to a proper tension. And you got to make sure that it doesn't wind up going cattywampus on you. If not, your alignment between these 2 points is going to go out. Rechecking the torque on these guys occasionally, great idea. You have dust and dirt built up in here. Simple soap and water solution and cleaning the dust and dirt from the inside of these portions will go a very long way in keeping these things running for a long time. Those ERV wedges can be taken out. If it's found in the OM, be very specific on how it tells you to do it. So it tells you to do it at 180 degrees. So take this wedge out and then take the one 180 degrees from it out, because the balance of that thing is going to shift very quickly. Mild soap and water cleans those. You can see it's got like a little bit of simple green to do it as well. You can see it has a belt on it and a pulley as well. Sitting right over there, line around the top.
Yeah.
There's another motor that's connected to that, keeping that thing working on a continuous basis. You want to check that pulley and you want to check that belt, but that's not like this stuff. You're not going to see all this black and all these different things and that different kind of reflection. What you're going to be looking for are these little notches to start disappearing. These little nubs, they'll start disappearing. You'll notice that these are all pushed out. They'll get real flat, and all of a sudden you'll start seeing the edges of these crack off. When they start cracking, that belt's getting ready to break. Replace it before it does, because a belt change on this is not an easy task. It takes 2 guys a couple hours.
At least it's not that old vinyl tube belt loop.
Oh. I know exactly what you're talking about. And yeah, inside of it, these dampers, this one and the fresh air intake damper, have to open 100%, and it's proved. Okay, what I mean by that is it has a set of end switches in there. If it doesn't open 100% and prove that it's open, it will not turn those fan motors on. Just like deadheading a pump, you can deadhead that motor and cause it to overamp very quickly. Okay, we have filters. I can see on 82119 they were changed. Maintaining these is a great thing. Back here, you can see your ERV wheel where it actually brings that return air up. Has a little bit of minor staining. That's turned yellow. It used to be kind of white. What we're worried about is this black following all the way through. When that black follows all the way through, it's now dirty and it has to be cleaned. Here's where your access to your motor.
What's the tube laying on top of that?
This guy? So that's actually verifying that the wheel's moving. It's an infrared eye. Yep. It's just it's seeing these little tracks right here go past it at a predetermined point and says, "Oh, I'm running."
Instead of putting a CT on the motor and say the motor's running, then you go up there and the belt's running, but they say the motor's running.
Exactly. All your line voltages. What powers these 2 motors are variable frequency drives. They're not just on and off. They are ramped. This is your system controller. It is telling you everything about how this system is operating. Your BAS is actually programmed directly into this Carroll controller. All of your settings, all of your faults, all your fault history that you're going to see on BAS comes directly from this Carroll controller. Down here, That's the contact for BAS. That light illuminates, telling you that there's a call for this ERV to be on. Differential pressure switches. This unit will tell you if you have dirty filters. It's looking at pressures on both sides of the filter, and if it sees too great of a pressure that it doesn't make this switch, it shuts off and throws you guys out an error and says, yeah, you guys didn't change your filters quite often.
Yeah, filters.
If you've changed your filters and you notice that there's dust inside these lines, dirt, or this thing can actually go bad. But if you see that kind of error, this is going to be the first place that you're looking at. How many CFMs are happening? And that will be measured on your BAS. Everything that you're seeing right here, how many CFMs are being exhausted out of the building, how many CFMs are being brought into the building, what the temperature is, what the differential pressure is between the return air and the entrance air, and that's why the variable frequency drives are needed, so that we're not just running full bore at all times. We may not need that, just like a VAV is dependent on a certain static pressure, so is this. Down through and into the space, right down. It's bringing air through the filter media, it's bringing air through the coil, and then projecting it down into space. This is two separate coils. This is a hot water coil and a chilled water coil. Okay, and what we're trying to do is condition the air before it gets down into the space.
So you got a freeze stat on it?
Yep, that's exactly what this is.
Automatic or manual?
Automatic. For some reason, this thing sees a freeze condition below 32 degrees. Actually, I think it's set at 33. If it sees a freeze condition, it will shut it down so that you don't burst that coil.
It'll bring the freeze pumps.
And it'll bring the freeze pumps on instead of blowing it. This one's got great deflection. I can barely move that guy, and if you felt inside of the last one versus this one's beautiful. You don't see as much debris. You don't see as much breakdown of belt nuts. So this one is in great shape. It's properly tightened, has been properly maintained. Just like the last one, we have a grease port bearing here, grease port on top of the motor, and grease port on the back of the motor, grease port on the other end of this shaft. Checking your belts, checking your shivs and pulleys, making sure they're completely 100% smooth. If they are not, there's an issue. You need to address it. You need to make sure this wheel stays clean. That small amount of dirt and dust collecting all the way around is throwing your balance off this bearing.